this. Okay. Okay. So we're building up this state chart. In Maine, we have population size, connection distance thresholds. We went to Maine and we set the network, space and networks, to have a distance-based network with a connection range, connection distance threshold. We set the population to have a initial number of agents, population size. We gave each person an income, and we made the incomes log normally distributed with a mu of 6 and a sigma of 2 and a minimum value of 0. And we made the initial locations x depend on income, y depend on this draw from over the uniformly from the space, the entire height of the space. And then we went to person and we added the state chart. This infection is based on a message transition, and we made it unconditional message. This infective one will be a timeout, and this one here, ladies and gentlemen, this waning immunity, we're going to call it waning immunity. This is going to be a rate transition. It's a hazard rate, ladies and gentlemen, no less. A hazard rate. Okay. Are we okay with that? Okay, now let us go repair to Maine and let us add 2 parameters. Okay? Okay. Great. Okay, so ladies and gentlemen, the first parameter will be a parameter called immunity, duration of immunity in days. Of immunity in days. And what sort of parameter will this be?
Time.
It'll be a time. And we'll pick days, and it will be 270. 270 days. Are we okay with that? By the way, one virtual, even though it doesn't automatically convert when you're using that in a hazard rate, one thing you can do very nicely is you can ask, convert this parameter to this given time unit, and it will convert it automatically for that. I mean, in other words, if you ask it, convert it, it will do it for you because it knows the time unit in which it's located. Okay, it knows its time unit. That much is good. Okay, so the 270 days, ladies and gentlemen. For the other parameter, we're going to have infection duration in days. Okay? Infection duration in days. And for this, I would like to also use a time parameter, and the infection duration should be 10 days. Okay? Okay. I actually don't have notes on that, but let's make it. Oh my gosh. Oh gosh. I destroyed it. Okay. Okay. Yeah. So duration of infection will be 10 days. So duration of infection in days. You notice by saying in days, I keep it from being misunderstood that someone else will see it and treat it as if it's a week quantity in weeks. By giving it that clear name, we at least head off that risk. Duration of infection days will be 10 days. Are we okay with that? Are we okay? Okay, ladies and gentlemen. Finally, there's going to be a contact rate, which will be this contact for transmitting infecting doses, and it will be, contact rate will be 1. This is also in Maine. And what sort of parameter will that be?
Rate.
A rate indeed.
Per day.
Per day rate of 1. Okay. ladies and gentlemen, we will now use these parameters in person. And meanwhile, I have a Krugerian request. Top priority is helping anyone, but could you check if an experiment, so if you have a parameter specified in days, as its stated default value, and then you have an experiment that specifies it in weeks, does it do the conversion there?
Sorry, say that again.
Well, okay.
Oh, I see.
Yeah.
Yeah.
Okay, ladies and gentlemen. So first, we'll go to this. To go to person, infective to recovered transition. We'll do that with the timeout of how are we going to refer to that parameter in main we created. Yeah, but we have to say main dot infection. Duration of infection in days, right? Is that right?
Infection.
Okay, you called it infection duration? I call it duration infection, okay. Potato. That's fine. Duration infection days, yeah. But the point is it lives in Maine. In waning of immunity here, we're going to make this main dot duration of immunity in days. Oh, sorry, excuse me. The rate is going to be what? So if there's a duration of immunity in days, the hazard rate of progression will be 1 divided by that, exactly. And to be careful here, to avoid missteps, make it 1.0 divided by it. The point is when you're dividing integer quantities, it's easy to put something down like 1/3 and think, oh, it should be 0.333, but it's because it's two integers, it's going to treat as 0. And that can cause a world of hurt for people. So, okay. So, ladies and gentlemen, what's missing? What's missing until we complete the transmission? Transition, great, okay. So that's missing. So we need a self-transition from infection to itself with rate what? We'll call this contact. And what rate is associated with that contact? Indeed, it'll be a rate as given by the main dot contact rate per day, right? Main dot. So I drew an internal transition here from it to itself. I made it a rate transition as dictated by main dot contact rate. And note that this is per day, right? Okay. Now, if we run the model, what will happen? Nothing. Why not?
No changing color.
Okay, that's most certainly true. So how are we going to remedy that?
Rail. Rail.
Okay.
Color.
Okay. Okay. Now, we almost have quorum here to use a non-American spelling, but I think we're outvoted. So we'll abide by the dictates of the American Imperium and make it COLOR. Okay.
Is there a way to use the LERP color with this so that each state would have like a varying shade depending on the number of people that are in there?
Yeah, there is actually. Do you want to do
I
that?
don't know. If it takes too much time, don't worry about it. I just that's the thing.
So you mean like each state would have a shade depending on?
If there's a ton of infective, it would say we have infective red. It would go from like a pink to like a hot red if there were a lot of people infected.
Okay, but the color like for a particular person, or would use it like at the aggregate level to illustrate like how bad is the situation? Because for a given person, they're going to either be in that state or not.
Okay.
But you could use it at the level of the population to illustrate it. And by the way, along these lines, system dynamics, one thing I didn't say this morning, but it bears note, system dynamics stock and flow illustrations, even if you're building an individual-based model, I love to build stock and flow models that count the number of people in each state and show how quickly they're moving between states. It can still be an extremely effective summary device used at an aggregate level for an individual-based model. right? To summarize how many people are here, here, or here, how many people are getting infected per unit time. And in fact, Dylan worked on a tool that automatically would try to generate that based on your underlying agent-based model, would generate a stock and flow depiction of it. So it could summarize it over time. Because it helps you think about it, okay, how many are in each state, to visualize it like that as well. And that's a little bit along the lines of what you're suggesting now. Okay, so we have a color. What sort of type is color? Indeed, other. And what sort of other? Color. With a capital C. Color. Okay. Okay.
Yes, if you change the unit in the simulation,
Yeah,
it changes it in.
it does.
Yeah.
So it's successful.
Yeah.
So that's sweet.
Yeah.
Yeah. Okay. So if in the
But then you're breaking
experiment,
the naming convention.
yeah, if you in the experiment you specified it in weeks, you would convert it automatically to days to use it in the model.
Yes.
Yeah.
I mean, it
Okay.
becomes that
Sweet.
week.
Okay. Yeah, but I mean, so I say 7 weeks, it would convert to 49 days using it in the model.
Oh, right, because it's
Yeah,
being treated on a per day basis.
exactly.
Mm.
So might want to investigate that. Yeah. Okay, color. Okay. So for ladies and gentlemen, susceptible, we're going to use the normal scheme. Susceptible is green. Infective is red. And I'm building this model both to exercise your comfort, to make sure that you feel comfortable, so that when I am gone, we're going to use lavender. I think this was a Nedian invention, using lavender for recovered.
No, his was magenta.
Oh, magenta. Okay, I'm sorry.
But lavender works too.
Okay, magenta. Sorry, I hashed them to the same bucket. Two colors. I don't really know what either means, but it sounds like a fancy color. Okay, magenta for recovered. Okay, and now let's color them accordingly. So we'll just, by good measure, green. This doesn't actually operationalize anything, but it's kind of nice for reference. And one of these, is this magenta? Ah, that's magenta. Okay. Okay. Is that okay? I don't know. I thought that's kind of lavender. Okay.
Oh, lavender is soft. Is duller.
Okay. Darker.
Yeah.
Okay. Okay, ladies and gentlemen. So we're almost
vibrant.
we're almost done with this. What's still remaining? If we run this, what's still? Have we finished the color story?
No.
Have we finished that chunk of work? Indeed, no. How are we going to color this guy? By color.
Project, person.
Okay, yeah, you folks are good, man. Shape body, okay. Shape body, okay. Great, and we're going to go down to fill color and make it dynamic color and have it say color, okay? Okay. 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 So, ladies and gentlemen, fill color is color for a shape body. Are we okay with that? So if we ran it, would anyone change color?
No.
Why not?
Message.
Oh, yes.
There needs to be somebody at the start, right?
Yeah.
Okay. So win one more for the Gipper. Let's go back to main and let's start someone in a state. Now we've done this in various ways. We've clicked on them. We've had them start a certain fraction in each. I'm just going to do it a quick way because this stands between us and lunch. So I'm going to create an event, initial infection event, and it's going to go off at time 0. Occurs once at time 0 days. And what does it need to do?
Infect a random person.
Infect a random person. And the way to do this, that's a straightforward way, is we could say this dot deliver to random agent inside. Remember, autocomplete is your friend. If anyone is typing that, it would be deadly. Well, not deadly, but it would be bad. So start typing this, deliver, control space. Okay? Control space. When I was in my last one in Melbourne, my last boot camp in Melbourne, maybe it was the first one there, in November, TAs suggested a policy that we refuse to correct spelling mistakes. The TAs would go on strike against spelling mistakes to compel them to use autocomplete, and I desisted off of that draconian policy. But it's a good point. Okay, deliver to random agent next time. I'm just going to say exposed. Now, the reason I'm being lax about this is this message is only going to have there's only going to be one message for this model, because you don't have to force someone to be infected. So I'm just going to be lax about that now. You know how to create an option list with messages. I don't need to show you how to do that. In this model, we don't need to pay attention which message is which, so I'm just going to do this.
Nate, do you need to create an option list all the time? You don't, do you?
No.
Okay.
Oh, I mean, here there's only one type of message. So as a result, I mean, the real reason you use an option list is you don't want to make a silly spelling mistake. Like put in an exclamation point here, forget it elsewhere, have it not work. But in this case, if you got a person, their handling of this message is unconditional. In other words, it doesn't test, is it equal to some particular message? So there's really no risk that it's going to be misunderstood.
But if you have on a particular message, and let's say you have two different messages, you still don't need the option.
You don't have to have it. I just find that it'll help at several levels. It'll help prevent a spelling mistake. It'll help, if you make a spelling mistake, it'll immediately correct it for you. And it helps you from having to remember what that message was and so on. So it's a bit nice, but it's not required. Yeah. Okay.
There's a principle in software engineering, and this would fit in that, is fail early, fail often.
If there's a problem, you want the model to tell you.
If there's a problem that happens, you want your model to tell you right away. So
you don't want it to stay hidden.
It's better to do it.
Especially until after you've gotten that paper accepted and then you discover, oh,
yeah,
there's a problem in those results.
Yeah. So that's abiding by that principle.
Yeah. So let's run the model. And Krugerian assistance is on tab. Okay. Oh, we forgot one critical thing. What did we forget?
Transmission.
Yes. Yeah. So we have contact transition, but what happens right now at that? It's full of sound and fury, and it signifies nothing. Okay. Right now, contact is leading to no action. What action needs to be the result of contact?
Send to random connected.
Indeed. This dot send to random connected, and we can send a message of our choosing because they handle it the same way no matter what message it is. So this is what I did. Send to random connected. Again, please type that. Please autocomplete that. Please don't have to type. Please don't make yourself type it.
So could you really have like typed anything?
Yes.
Like except like just like gibberish instead of exposed.
Well, it would have to be in quotes.
Yes.
Yeah.
Yeah. It has to be a string. Or I mean, you could also send the number, couldn't you?
Yeah, you could send a number.
Yeah.
Yeah. I mean,
Quotes means a string. You could send it this. You could send it itself. You don't have to send a string across. In fact, one technique you can do is when you're sending a message saying I'm infecting you, you could send, for example, who is the infector.
right.
If that was important for you to keep track of that,
Okay.
right? So if, for example, you have a friend who's more likely to, like, that infection transition is going to be a higher likelihood than it is with a stranger, or more with a mother than with a child, something. So you could send different types of information.
That's right. You
But
can
we have
pack
that-
up a lot of information in the message. And actually, sender is one of the things that AnyLogic has traditionally let you extract. Although this version has made it, it's changed, I think, the way that it does it. In any case, you can extract who's the sender for a message. But one way to do it is just send it along as the message. Or send along, the sender and where it occurred, or whatever, the nature of the contact. And you could, the receiver could receive it. So messages aren't just like, some name. It can sometimes be providing actually a lot of information.
Is there a location that would be displayed if you wanted to follow individuals about who they were exposed by?
Yeah. Could you follow individuals?
Yeah,
Absolutely.
Would that be displayed like in Run in a way like a table? Saying
So you could record each time someone gets infected here who infected them and the time of that. And in fact, I may have provided you with a model which does that.
Remember that trace LN thing?
Yeah.
So you could print that out to the screen.
Okay.
But if you want to, and we haven't, hopefully we'll touch into it today. But you can generate basically files.
Mm-hmm.
So you can generate output files, comma separated files or Excel files or whatever. And so then it would be basically a log run of your entire model. If that was something that you wanted to track,
Okay.
you could bring it into R and do some analysis on it, or you could use it for debugging purposes.
Yeah.
Could you just go back and show the transitions again? I want to make sure I got the messages right.
Sure. So for the transitions, this one here is a message transition that's unconditional.
All right.
For this contact transition, this is occurring at a rate of main.contact rate per day, and it's sent to random connected, and the message is fairly immaterial.
Oh, that's why I had it as years.
Oh yeah, per day. Per day.
I had it as per millisecond when I was testing it. Very.
That is main duration of infection in days.
And this is duration of infection in days as a timeout,
Yeah.
and this is waning of immunity as a rate of 1 over that.
Yeah.
Okay. Okay, ladies and gentlemen. Okay. So I'd like to, if we run this thing now, we should see infection spread, and right now it actually is set so that it dies out. So in other words, people recover, and by the time someone recovers, there's no one around infected. If we were to change this, the assumptions here.
It could be based on your random number too, though. Other people may experience differently.
If they have some difference in how they implemented it, yeah. Or if they have a different random number. So if we were to do this with a shorter duration of immunity, for example, it may be that we would see a recurrence. So if we had 30 days as the duration of immunity, I'm going to create a new experiment. And in general, you're going to create multiple experiments for your models because you want to run it with a set of scenarios. And even as the model evolves, you often run the same scenarios. So this would be, brief, month-long immunity or something like that. So if the OPA type associated with gonorrhea is changing very quickly in the area, now we have people losing immunity in time that people around them are still infected, and the infection will persist. So what I did is I created a new experiment with a duration of immunity instead of being 270 days of just 30 days, which is on the order of what's been suggested for certain STIs because of evolution of the outer membrane protein or what have you, and with that we get a very different epidemiological outcome. We get ongoing circulation of infection. Okay, now before we break for lunch, I have a challenge for you. The first challenge is I want to plot out the prevalence of infection. How did we do that? Very common need. Add a stat.
In Maine.
Good.
To population.
Good. Add a stat in Maine. So we're going to add a statistic here to Maine that's going to be, it's in the population in Maine, right? Remember that? And this is going to be prevalence of infection. Now, I'm actually going to say fractional prevalence of infection, not prevalent case count, fractional prevalence, like 0.3. Okay, now does anyone remember how we did this? We did it once, and I want to reinforce this because it's a very common statistic. And I've been on AnyLogic's case to make it something you could do just by declaring it directly without you having to do the computations. But what did we do? I'll give you a hint. It was an average. What was that average?
Population size and
Okay, we could do it with population size. It's true. We could sum up for each person the population. If they're infected, sum up 1 over population size. But there's an easier way with average to do it. What is it? Anyone remember? Okay, we take the average. If they're infected, we treat them as a 1. Otherwise, we treat them as a 0. And we take the average over the population. So imagine 50% of people are infected, therefore 1. 50% are not infected, therefore 0. The average over the population is 0.5. If 25% of the people are infected, 1. The other 75% are 0. The average is 0.25. It's the fraction that are infected. It's a very straightforward way to do it. So we do it straightforward. Takes a little bit of thinking, but so common. It's worth knowing as a pattern. Okay. So the expression here, we have to specify what value is it for a given person. And that person is called, does anyone remember? What is that person called here?
self.
No, they're called
Item. Name.
item.
Of course they are.
Good call with self. Good call. But, it's called item. How do we know that? Because it provides it in this little light bulb. Item dot. And then we're going to ask what? If they're affected, how are we going to ask that?
In state.
In state, yeah. Now, the more beautiful way to do this is to add a parameter to them that says is infected, and it returns whether they're in that state, and then if their states evolve, then it doesn't have to change. But we'll leave that nicety to the advanced boot camp in August. Item dot in state, and what's the state? Person dot infective. Ladies and gentlemen, if that is true, then what value are we going to give them? 1.0. Otherwise, 0.0. Now we're going to have a prevalence of infection. Are we okay with that? Cool. How can we test if this is running? You do a little chunk of work and you want to test it. Yes, we could go add a graph, but how can we test it right now?
Adding a trace.
We could do a trace LN, but we can actually do it in an easier way yet, and it's good to know about these things in AnyLogic. Let's go run it. And there's another way you can get at population statistics. You can click on the population. Oh, gosh, not like that. There you go. You see that? Population, the population prevalence. We could actually do copy and we could paste it somewhere else. Population prevalence. Okay? It ain't pretty, but it gets the job done. You can tell if it's working, very likely. Okay? Ladies and gentlemen. Okay, now it's getting to sort of an endemic state, yeah. Okay. But we want to go further than that, ladies and gentlemen. We'd like to go, and this is a challenge. This is part of the challenge. Go to the palette. I would like you to add a pie chart that shows what fraction of the population is currently infected. From whence will that pie chart come?
From analysis.
From analysis, indeed. Okay, and there's a pie chart. Let's drag it out. Okay, drag it out, and let's fit her out. Okay, here's going to be our pie chart. Now, you folks, there will be a time, not long from now, where I will not be in this room for consultation, and won't even be in this country for consultation. And so we got to learn to have a measure of comfort with AnyLogic, learning new things in AnyLogic. Here's a chart. I'll give you a name for it. This will be, population health status chart. How's that for a name? What do we need to do to get this chart show some data? Yeah, we go down and we do data. Okay, and what do you think we do to data?
Plus.
Plus, indeed. Okay, now it says item. What do you think this item will be? It's actually, this item is one slice of the pie. Now, it happens to be a chocolate slice in mine at the moment. Chocolate pie as of yet. But that won't always be the case. There may be key lime that's eventually mixed in there too. Okay, ladies and gentlemen, we're going to divide this into 3 states. Susceptible, and what color shall we use for susceptible to be consistent color-wise?
Lime.
Lime. Okay, now we have a lime pie. Yeah. Okay. And what do you think its value will be? Okay. For this, how will we give it a value? We want the number that is susceptible. How will we do that? How do we get the number that are susceptible?
In states.
Okay, yeah, we could say in-state, but that's going to answer for a particular person. How are we going to get a total of the number that are susceptible? How are we going to get a total across the population of the number that are susceptible?
Population size.
Good. Okay, population size would be the total number.
Oh, so do we need any stats?
Yeah, we do it in stats. Okay. So this is another stat. We'll do one stat for each of those.
She wasn't even here yesterday.
I know. I'm impressed. Impressed. Yeah. Impressed. Okay. So count susceptible. Is this going to be a count, a sum, an average, a min, or a max?
Count.
Indeed. And what is it going to count?
In states.
Okay. Good. And who's going to be in the state? Is it self? Is it person?
Item.
It is item. Item dot in state, and we got to go through this little ritual of saying person dot, because it's, in fact, it's susceptibility with respect to person. There may be, you may have deer in your model, or moose, or hyena, or coyote, or whatever, right? All sorts of different things. Susceptible. Okay. Are we okay with that? Okay, let's do the same for infected, and let's do the same for recovered. Okay, so count susceptible, count infective. What is, for count infective, what are we asking?
Same thing.
But person dot what? Infective, indeed. You got the gist of it. Okay. The next, count recovered.
Yeah.
Okay. Item dot in state person dot recovered. Okay. Sometimes it's hard, sometimes it's just tedious. But that gives us 3 things. Having done that, we can now use them. Okay, so ladies and gentlemen, we want that now to appear up at the top. We want it to appear for the pie chart. How am I going to do this now? With those defined, what am I going to do?
Go to point your data.
Okay, so go down to data, and what are we going to do for data? So for the number susceptible, what are we going to enter now? Okay, who knows about count susceptible? Well, okay, but what in Maine? Population. It's the population. So really, I should say this dot populate. Well, if you don't have to say this if you don't want it. Population dot count susceptible. Boom, just like that. Are we okay with that? Okay, now let's do the same. It looks like somehow they lost the liveness. Okay, Okay, next, I'd like you to do infective. Infective. And what color shall we give this? Red indeed. And what am I going to put as the expression? Dot population dot count infective. Excellent, excellent. Okay. Okay, ladies and gentlemen, next, what do we do? We're covered. We're covered. Okay, and let's give it a lavender. Sorry, magenta. Sorry. Okay, population dot count magenta. Oop, count magenta. Count recovered. Okay. Are we okay with that?
Yes.
Okay.
Value is going to be population dot, or this dot population. You can auto complete that. Press enter. You can just press enter on the first name. You don't have to click. Yeah. Dot. Count. And then auto complete. So we're going to see count infectives.
Okay. Oh, look at that. Somehow, though, the colors, I don't know, the colors are, somehow for me, I think it's just a refresh thing. It's just, try it. Okay, ladies and gentlemen, those who have it should be able to run it.
Can I ask something?
Sure.
I just can remember so it's giving some percentage to each one of the groups.
Yeah. Just like this, or, a share of the pie.
Yeah, so is that drawing it from the distribution that we had, or?
Oh, it's measuring it from the population. So,
Okay.
in other words, those are using statistics, which are
You're going to see
computed here across the population. So each time we ask for that, it's totaling up across the population. How many people are susceptible, number of people that are infected. It's actually counting them
You
up
have 3 because we missed
one by one.
Yeah.
And that's what's leading it to show this. Is that okay?
Yeah.
Yeah. Okay.
What did I miss?
Okay, ladies and gentlemen. Okay. So that's good. So here we have this pie chart, and we should really have
It'd be really nice if
it'd be really nice if it had a label for that somehow. If this pie chart allowed you to say put a legend in, right? A legend. There's a legend. It says show legend. Okay, so it's saying to show the legend, but I don't. Does anyone see a legend for
I
it?
forgot the semicolon.
I see one.
I got messed
Okay,
up.
you know where it is? It's down here.
What the hell did I do wrong?
Ladies and gentlemen,
No problem at all.
so ladies and gentlemen, we want to drag this up so we can see the legend. There's a legend beneath it. Beneath it. Okay?
There's no betweenst version of it.
I know, I was trying to
I know.
struggle. Beneath it, folks.
Beneath.
There's a legend beneath it. The legend lies beneath it. Okay? Okay, so now we should see this. Something like that, right? And as this runs, this is going to grow and come. This is summarizing the current state of the population, right? Okay.
Will that accomplish something similar to what you were saying with the stocks and flows to see kind of a higher level? where-
This gives a sense of what fraction of the population is in each of these categories right now. What it's missing still, and what we're going to be filling in after lunch, is how many people are going from one to the other, which is going to require more. Okay, but we still haven't finished the task that I first set out there, which is I want a time plot of the prevalence of infection, the fractional prevalence of infection. You've done that before. This is going to be prevalence plot. So I'd like you to drag a time plot there, make it a prevalence plot, and I want to make it data here is going to be fractional prevalence of infection for the time plot.
So Nate,
Yes.
this is is an interesting behavior.
Okay.
If you go into your state chart,
Pipeline.
the person's state chart, and your infection transition leaves the state,
Goes out and comes in. Then yes, then that will lead to
then what happens is that at the main level,
yes.
you don't have anybody counting as in the infective state, or like a small number of people that happen to be not hitting that infection transition. Does that make sense? So it doesn't count them as in the state. Does it make sense? Give it a try.
Okay, I will investigate that. That surprises me
Yeah. So
greatly.
So we've seen this before. So on these self transitions, if your self transition sort of exits the state and then points back to it, rather than going through the middle of the state, then so what we found is that the count of the people that are that seems to infect how it counts the number of infectives or
Wow.
the number of
Okay, now you could
Although
work around that
here's
with the technique Nick maybe was suggested, which was counting manually sort of the number that are in that state by incrementing a count or whatever, decrementing.
that was
Someone suggested that, and
Was not-
and that would allow you to work around it, but that disturbs me. I want to look into that.
Let me verify it.
Okay, ladies and gentlemen, so for this time plot, I would like to plot out the fractional prevalence of infection. How am I going to plot that? What am I going to plot? A value of what? So I did plus to display this.
I guess that makes sense.
What do I want to
These are
plot?
infectives. These are all infected people.
What do I want to plot?
Leaving in there, the word infected event.
Ladies and gentlemen?
So I'm
They're,
saying
they're
population.
staying.
Population.
Yeah, population and then what?
Is that not?
Oh no, I got it.
That would be cool.
Fractional prevalence of infection. Remember we defined that?
Yeah.
Remember that? There
This
we go.
time, this recovery time, the timeout, is a certain number of days.
Okay.
I figured out the problem. It's the timeout. It keeps getting reset.
Yes,
So
exactly.
they never leave.
That's definitely the case.
Yeah.
Yeah, I was thinking about
Yeah.
mentioning.
So what happens is if it goes out, then every time it goes out, then comes back in. the
It
timeout
restarts
is
the timeout.
restarted.
Oh, wow.
Yeah.
You
Okay.
cannot consider it infected.
So, ladies and gentlemen, I made this.
Entering.
I made this time plot. I dragged in a
You wanna
time
keep it on
plot.
the inside.
I created a data item.
Thank you.
It is this fractional prevalence of infection, and call that fractional prevalence of infection. Where did this come from? Who defined this? Yeah, we did together. Okay, good. And ladies and gentlemen, I'd like you now to, okay, so we're going to have 100 model time units. Okay, in that case, this is okay, 100 days. I'm willing to live with that. So we should be able to run it now. Who would like me to show something? Could I show something?
If it's fast.
What's that?
If it's fast, you can.
Okay, sure. Would you like me to show?
Yes.
Show this? This is the time plot. I dragged in a time plot. I added a data item, and then I did this.
Oh, sorry. I thought you meant show something else. Yes.
Oh,
I know
But
that.
this has
sorry.
been great.
sorry.
No, keep going for it.
Yeah, no, just do it again.
Okay. Oh, you want to see it?
Oh, okay.
You want to see that?
Yeah.
Okay.
That one's
For
good.
those who would like to see something else, I can show that at the same
Yeah,
time.
no, you can, I got it.
Okay.
Thanks.
So we're getting some fluctuations. Considerable fluctuations. Look at that. 0.08 up to about 0.22.
It does have.
Okay. Okay. Now, okay, we're at the cusp of lunch. The cusp of lunch. But
Of the crown jewel of lunch.
okay.
Just depends on what your lunch is going to be, but
Okay. Okay.
Is your
Are you willing to win one more for the Gipper? Or should we go to lunch now?
Anything okay?
Let's win one more.
I just that's
One more? Okay, okay, I admire ambition. That's great. Okay, ladies and gentlemen.
Ambition and stupidity are pretty
You
one
should
and the
ask.
same.
I think I should know.
Okay,
That's unfair.
so here's my challenge to you. I would like to display the number of the incident case count once a week. The incident case count. So how many people over the past week have gotten infected? How are we going to do that? Can we do that in the statistics for the population? Mark my words. I told you previously in the week, and I'll repeat it here. The built-in statistics for AnyLogic are great for cross-sectional statistics. They summarize the state of the model right now by totaling up across the population. Is incident case count of that sort? No, it's accumulating over a week. So how will we do that?
Create a variable.
Indeed. Indeed. And that is the heart of the matter. Create a variable. Whither will that variable live? In Maine. It will live in Maine, indeed. Indeed. It will live in Maine. And what will that variable, of what will that variable keep track? Number of people who have gotten infected as a running total for this week.
Just make some noise.
And then it will be reported, and then it will be reset to 0. It's like having that clipboard, right? Oh, someone got infected again. You nick it down, boom, cross off, keep on doing that to the end of the week. You crumple up that paper, you report it, crumple up the paper, throw it out, you're starting on a fresh slate. 0 for the next week. Are we ready to do this? It won't take long, ladies and gentlemen. And I admire ambition. Let's put in place something that once a week will report it and reset it. How are we going to do that? Well, first let's create a variable, okay? So this variable will be called running count of infections,
Weekly infections.
or of incident cases for a week. Of weekly incident cases. Okay, of weekly incident cases. Okay, I like that. With WEEK, weekly incident cases. Yeah?
Oh, instead of not very strongly.
Right. Right. Okay, of weekly incident cases. Yeah. Of like that. Are we okay with that? And what sort of thing will it be? Double?
Integer.
An integer indeed. It's a count, ladies and gentlemen. And its initial value will be what? 0. Yeah. Partial people are the province of aggregate models. Aggregate.
I've met some people that would consider half of mine.
Well, I guess that would be weekly with a WEAK instead of cases.
Weekly.
Yeah. Okay. So the initial value will be 0. Okay. Now, once a week, we want to report that value and reset it to 0. So how are we going to make something happen once a week on the week?
Event.
An event, indeed. So this will be called incident case reporting event. Incident case count reporting event. Not case. It's not like every case counts. Case, or incident case weekly reporting event. I like that. Okay. Okay. So what sort of trigger will this be? Be a timeout. And what mode?
Cyclic.
It'll be, yeah, exactly. It'll be cycling. Okay. Okay, great. So the first time it will fire off will be 0 days, and then recurrence time is every how many days?
7.
Indeed, ladies and gentlemen, indeed. Okay. Okay. Okay, this is proceeding quickly. Now, the job of an event in life, ladies and gentlemen, is to fire off, but to do something when fired. I mean, you can fire off, but if it doesn't do anything, it's not serving a lot of good. It does something. It performs an action. Hence, action here. Okay? hence action. Ladies and gentlemen, may I ask, what will this do? What will this need to do? Two things. One of which is obvious from its name, report. How are we going to do it?
Call the variable.
Indeed. Okay, it will print this, it'll print out the variable. Okay, now, with your leave, I'm going to ask you to drag in also a data set, which will be called incident case count. Data set. Incident case count data set. Are we okay with that?
Where can I find a data set?
It's under the analysis tab of the palette.
Gotcha.
Yeah, and mind you, there's a couple types, but it's the one at the top.
Gotcha.
Yeah, okay. Incident case count data set. Now, they set it with a miserly thing, a number of samples. Keep up to at least 1,000 samples, okay? Great. And do not update data automatically. We will tell it to put data in there. Are we ready? Kurt is ready for consultation. Are we ready? Okay. So incident case count data set. All I did is I set it to keep up to 1,000 samples, and I gave it a name worthy of it. Okay. For the event, this is what I'd like you to do. For the action in the event, I'd like you to trace ln, and it should say in the trace ln time. This is a very useful factoid to know you can call time like this and get the current time. And I'm going to do colon time colon incident. Okay, maybe what we'll do, we'll do \t. This means a tab character, and then we will do the running count of weekly cases. Do we need a semicolon at the end? Yes, because it's a command. It's something, print this out. Okay, are we okay with that? Next, ladies and gentlemen, trying to teach you life skills. This dot, by the way, I could have done this dot running count if you want to be careful about it. Incident case count data set dot add. And what do you think I'll add into this?
The variable.
The variable, indeed. Ladies and gentlemen, this dot incident case count data set dot add, that thing. And then, ladies and gentlemen, what do I need to do to get this variable ready for the next week? I need to reset it to what? To 0. This dot running count of weekly data cases equals 0. And that, ladies and gentlemen, concludes our event. That concludes our challenge. And that concludes a crowning jewel. Okay? So let's walk down through this. Oh, this thing is wrapping in an unseemly fashion. It's unfortunate because it's wrapping something at an unfortunate place. Here we go. Ready? There we go. This is a bit smaller, but clear. So first, we're printing out this. What does this do? This basically asks. It includes starting time, and then it puts a tab after it, and then it puts the running count. So thus far, and then I put that running count in a data set for future reference, and we'll see how useful that is in just a minute. Finally, I reset the running count. That's like crumpling up my paper, throwing it out, starting with a clean slate for the coming week. Are we okay with that?
Somehow I ended up deleting everything in that box by typing once. Like, what the heck did you do?
Ooh.
You should be able to do undo.
One of the most useful keys of AnyLogic is undo.
It's sometimes you have to click out of the box that you're trying to.
Yeah. Oh, gosh, I almost forgot, ladies and gentlemen. But this is definitely worth knowing about. One of the most other useful keys, undo. The undo, Control Z or undo, edit undo. But let me show you another super useful key. Can I show it? Control F. Also can be found as search replace. Watch this. I'm going to say susceptible. Okay? I'm going to search for this. Watch this. Search. It's going to show me all the places in the model where susceptible can be found. So, it can be found here in the pie chart. It can be found in the population under count susceptible. It can also be found in the person in the state chart for susceptible. Right? That's a very useful key to be able to search within the model. Key use. I use it all the time to find things. Okay, ladies and gentlemen, may we run the model? Oh, sorry. One thing have we forgotten? A key thing. Arguably the. Okay, no, it's.
You're not adding stuff to the variable.
Yeah, we need. Okay, so we're reporting this variable, great, but who's adding to it? Nobody right now. So when do we need to add to that variable? This running count of infections. When there's a. Okay, and when there's an infection, right? So the incident, we need to increase the incident case count when there's an incident case. And where in the model, wherefore lies the infection?
Infective state when they enter the infective
Okay,
state.
it could be enter the infective state. That would be perfectly good. Give me another place it could be. Could be right here. We can put it either place. Now, why would you put it into one or the other? Well, this one, in as much as it says infection, might be a natural place, but there might be a really compelling reason to put it in here if there were two transitions, maybe one for force infection, one for case. So either one would fit the job. I'm going to put it in the transition, but that's without privilege. So I'm going to put it in the transition, and the action for the transition, what am I going to type here? What will I type?
You're trying to score the number of infections this time.
Yeah. So we're going to be increasing this. Good. Excellent. Main dot. Oops. There we go. Main dot what?
Blah blah long name, which
Exactly.
That's important to know, and it starts with
running
auto-completed.
Running count. Okay. Yeah. And then what? Plus. That just increments it. Okay. Semicolon. Because it tells it, do this. Make it one bigger. Are we okay with that? Okay, ladies and gentlemen, shall we run it? Will we see any evidence of it? Wherein will that evidence lie?
In the thing, the
Oh.
data set.
Okay, it's an unhappy camper though. Mine is an O. I put a thing after that. Okay,
What was wrong?
I accidentally put a D after the semicolon,
Oh.
which made it unhappy. Okay, so where will we see this thing?
The trace in the data set.
In the trace and in the data set. Okay, ladies and gentlemen. Okay. Okay, now we're having 2 incident case counts, 3 incident case counts. Do you see this? In this data set? I clicked on this data set to see it. Do you see that? Alternatively, wherein does it occur?
The console.
Under the console. Here it is, printing out. Do you see that? Ladies and gentlemen, right click on this. Right click, do copy. And now go to Excel and paste, and you should see the numbers here. From right clicking, copy, and then doing paste. You should see this count.
Do you have
Who's your best
to
friend?
copy when the model is done running, or when it's,
What do you-
that
Nope.
doesn't matter?
At any point.
Well, you could copy at any point in time. You know, for your interest, maybe your interests are to have the full run. You know, but for now you could plot there, and because you can do that, you know, we could readily do this. Incidentally, we have a tool that automatically outputs to R all these data sets. So it automatically, you call up R and you run one command, I think it is, and it will automatically inject all the data sets as a data frame in R that you can then plot out or what have you. So, you know, we could go plot these in Excel as well, right? So we could go do insert and do a line graph and plot this out. Okay, well, that's not that useful. I'll get rid of this. Hey, oh.
Leaves a message. Yeah.
Okay, plot this out over time.
Yeah, so that's
What do I
a good
want to
question.
do? I want to
That's not what
plot
we
out,
do
I could just
actually.
do, oh, come on. Let me just
Yeah,
plot out the
you
second
want
column.
conditionally.
Okay, there we go.
There is no
Insert, as a line, boom, okay.
Sort of adds
In this
that.
case, count, right? Okay. Okay, ladies and gentlemen. I think it's time for lunch. After lunch, we'll look at one or two extra metrics, like keeping track of the number of times a given person has been infected, and that's variability in the population. So longitudinal measures. Maybe the total length of time someone has spent with infection, cumulatively.
Oh, it just changed.
And we will see how we can do histograms that update periodically with that.
It should
And
remove that.
then we will additionally put in place a mechanism for this model for to output to a file.
That's about it.
Okay? And if there's interest, I could show how you'd import parameters from a file
Yeah.
to run for experiments. So you could have a Excel file where you tweak parameters and it's automatically run, when the model runs, it reads from that Excel file. Okay? So input and output to files in Excel. Okay? So we'll do that after lunch. Okay. Great. So I know some of you are interested in talking with Kurt and I over lunch, and I'd be happy to do so. Ned, I think I offered to talk with you a little bit more over lunch. I'm going to run up and get us away, but I'll be right back, and we can do that then. And depending how those conversations go, Kim, I might be able to further talk with you. I don't know, Kurt, if you have someone that's going to be talking with you over lunch too.
If we could have a chat about that more.
Yeah,
Sure. Yeah.
that'd be great. Okay.
Sean, can I have my computer here? Are you guys gonna lock the door or?
I can be here.
Okay.
Yeah, we can show it. Just wanna.
Yeah.
No, I'm gonna go get some soup, but
Yeah, I'll be.
From just across the way?
right here.
Just from here?
Yeah.
Oh.
They have sandwiches
Chicken noodle and minestrone.
and
Minestrone.
If you want to roll the dice. California. I really almost had it. Is it? I was thinking I have sushi.
It's not too bad.
It's not too bad. Well, I lived in Japan for 2 years.
Okay.
So that means a lot then.
So you have a
Right?
standard.
Well, it's, yeah.
So many
It's
people
edible.
many people eat it, so.
It's edible.
And better than other stuff, maybe.
I think I'm gonna look at the soup here, and not
Good.
go. It's a little quicker.
Sure.